Hi, welcome to the Shikho Math Lab Mathematical Statistical Problem Solving Sections. So today we're going to work on the conditional probabilities here. And for this problem, if you just look at the problem, it's kind of the intuitively makes sense. So like it tell you the probability of the A given E greater than the probability of the B given E. And the same time, the probability of A given the E complement and the greater than probability of the B given the E complement. So it's kind of like intuitive. You say, oh yeah, because the both condition, the PA given E greater than PB given E or PA given E complement greater than PB complement. So kind of intuitively true, PA is greater than PBs, right? So now in here, so how do we prove it? So that's why today we're going to take a look at how do we prove this statement here, all right? All right, before we start, let me just write out the conditional probability, the definitions here. So here is we know if A given B is so this is based on our rules. We know this is the PB, and that this is the P, the A intersect the B's here. Okay, so now let's go ahead to start with our conditions here. So the first ones we said A given E. Okay, so A given E, this is what based on, so this is a PE, and this is a PA intersect E. And also we know from the problem we say this one is greater than probability the B given E. So what is the probability of a B given E is here is a PE, and this is the probability B intersect E is here, right? So from here, they have the what? They have the same denominator. So if they have the same denominator, one is greater than other one. So what is this one we can conclude? We can conclude that A intersect E has to be greater than equal to the B intersect E here. Okay, so the same argument we can use for the A to the complement here. So this will be probability E to the complement. Then we have A intersect E to the complement. So the problem tell us that this is greater than probability of the B given the E complement. So this one will be probability the E complement, and this is a probability the B intersect E complement, right? So both I just applied a very basic our conditional probability definition. So the same here for these ones here, they have the same denominator. So if this quantity is bigger, so that means apply what? So apply the A intersect E complement. Okay, greater than probability B intersect E complement here. Okay, all right, so now from these truths here, so if you combine the, okay, so let's take a look. So if you add these two, all right, so if you add these two, so I know the probability of the A intersect E plus probability of the A intersect the E complement going to be greater than or equal to, okay, so going to be greater than or equal to the probability the B given B intersect E, right? B intersect E plus the probability B intersect E complement here. So, okay, so now I know, right? So I know the A, E, and so if you union the E and the E complement, what is this one going to be? Will be the whole sample space, right? Okay, so like then I know the A you can rewrite A. Anything intersect the sample space will be itself. So A you can write as A, and this is going to be E union E complement, right? So here I need to. So this is A intersect. Okay. So now because these two E and E complement are disjoint, so that's why I can write this is the A intersect E. All right. Then union A intersect E complement. So that's why now if you put the probability on both sides, so the PA will just be equal to the probability, the A inter E, intersection E plus the probability that A intersect E plus, right? So that's why for these terms here, I can say this is equal to the probability of the A's here. All right. So the reason why, okay, so the reason why from here to here, I can write the probability here. It is because A intersect E and A intersect E complement. What are these two sets here? These two sets are the disjoint, right? Because E, because we know the E and the E complement, they are disjoint here, right? So those disjoint. So the disjoint name, you can just add them together. So next, the same things here, you can apply the same thing. So that this is the B, you just replace the B with A. So what is this one here? This one is PBs, right? So that is why, that is how we proved PA greater than equal to PBs here. It's a pretty simple proof here, but I think this is a good problem because we go back to the several fundamental steps, the definitions, right? So we know the definition of the conditional probability. Then we also need to know like the any set union is a complement, it's a sample space. Then any set intersect sample space will be itself here. That's the key concept, right? Now after that we can break this one. So then also use the theories, the additional theory, because these two sets are disjoint. So when you try to find the PA, just be the probability of the A intersect E plus probability of the A intersect E complement here. All right, that's it. And I think it's a simple problem, but it's a problem including the several skills here. All right, nice talk to you, and looking forward to work with you for another interesting problem. Okay, bye. Have a good day.